The personal protective equipment, PPE, worn by actors in this video was selected based on a risk assessment of the chemicals used in the experiment and conditions simulated in the activity. In scenes where the presenter did not wear PPE while in the lab, all chemicals were removed to eliminate chemical hazards.
Most scientists work with chemicals as part of their career, and the progress of science depends upon this. But working with chemicals has inherent hazards. They can be corrosive, toxic, reactive, or flammable. There's also risk when using lab equipment, especially when high temperatures or pressure are involved. In this video, you'll learn how to evaluate the risk posed by hazards in the lab. Assessing risk is part of a larger process called RAMP. RAMP stands for Recognize Hazards, Assess Risks, Minimize Risks, and Prepare for Emergencies. This is a process of risk management, which is important to ensure your safety and the safety of everyone around you in the lab. For this video, we'll assume you've already completed the first step of RAMP, Recognize Hazards. Because we'll be talking about hazard and risk, we should quickly look at the difference between the two. A hazard is a source of potential harm. For chemicals, hazards are intrinsic, and the amount of a chemical doesn't change the hazard. 1 drop of gasoline is just as flammable as 1 gallon of gasoline. Risk is a product of the severity of hazard and the likelihood of occurrence. We'll refer to this equation as the risk equation. Risk is often represented in a matrix. One axis of the matrix is severity, and one axis is likelihood. We'll assign levels of severity such as low, medium, or high for various hazards. Based on the lab procedure, we also can estimate the likelihood of exposure or occurrence as low, medium, or high. Evaluating risk can be subjective. Experienced chemists may be able to handle equipment very safely in situations where a novice might be prone to error. Here's an example from daily life that shows how we can use this risk matrix. Lightning is a known hazard, but on a clear day, there's a very low risk of being struck by lightning. There are also several simple things you can do to minimize the risk of being exposed to lightning during a thunderstorm. For example, you can stay inside, or if you're stuck outside, you can avoid tall objects such as trees or flagpoles. You can use the same type of thinking to protect yourself in the lab. Almost every experiment you do will have some hazards, but by following basic safety precautions, you can reduce the risk of injury from those hazards. Make sense? Now let's look at some examples of risk management in the lab. A student needs to pour a solution of a strong acid into a burette. This represents a medium or high severity level in the matrix depending upon concentration. The likelihood of exposure, most likely from spilling the solution, depends on several factors. These include what glassware is being used and the student's skill in pouring. Let's judge this as a medium likelihood of exposure. Using the risk equation and taking these factors into account, we can see this procedure is medium or high risk. This tells us we should redesign the experiment to reduce the risk level. For example, using a funnel, lowering the burette, or using a small beaker to pour from reduces the likelihood of a spill. Wearing appropriate eye protection and gloves reduces the chance of exposure. In our second example, we want to dilute concentrated sulfuric acid. We're working with a concentrated strong acid, so the level of severity is rated high because it is corrosive to skin and eyes. The likelihood of exposure is medium. This gives an overall risk of medium or high risk, which means we should reduce the risk if possible. Wearing eye protection and acid-resistant gloves will reduce exposure. But wait, there's another hazard we haven't recognized. Adding water to a strong acid creates an exothermic reaction that generates heat. By slowly adding the acid to the water while stirring, the heat is released and absorbed by the water. This reduces the chance of splattering and exposure. Other videos in this series address techniques and strategies for minimizing risk. Assessing risk may sound easy, but it's quite often difficult. Why? First, while hazards are easy to identify, assessing their severity is more challenging. You may encounter some terms describing quantitative measurements of hazards. Some examples are LD50, a permissible exposure limit, or a flash point. You'll need to understand what these values mean and how they influence the actual risk posed. We can't get into a full discussion of these terms in this video, but you need to know that they often make this a complicated process involving judgment calls based on skill and experience. Second, the likelihood of exposure depends on your level of experience in the lab. As we mentioned earlier, your experience level can vary from almost none, when you start taking college chemistry courses to pretty good by the time you graduate. Finally, what level of risk is acceptable? We generally want this to be low, but different people might judge the same level of risk as okay or too high. This will affect which techniques for minimizing risk should be used. You won't have to make risk assessment decisions in general chemistry courses. Most lab experiments have been designed for you already and are low risk. However, later in your academic and professional career, an important responsibility of your lab work will include assessing risk. So this is an important skill to develop. The process of assessing risk is part of the RAMP protocol. RAMP stands for Recognize Hazards, Assess Risks, Minimize Risks, and Prepare for Emergencies. To learn more about RAMP, be sure to check out the other 5 videos in this series. You can find them by clicking here, checking out the links in the description, or visiting acs.org/safetyvideos.
Call it.